Thanks, Ryan. Thanks,
No worries.
everybody who joined the talk. Yeah, my name is Pavlo. Today I want to talk about Jetpack Compose and specifically, how to migrate or start migrating your existing app that relies on fragments. How to start adopting Jetpack Compose in a way that you don't have to rewrite the entire application for the new UI toolkit. So we'll talk about how the new and old screens can coexist in the app efficiently and how you can easily navigate between them. And I just want to share experience of how it was done at Turo. And hopefully it will be insightful for folks who are watching this talk. Right, before that, just a few words about me. I'm Pavlo. I'm Google developer expert for Android and Kotlin, and I also work at Turo as a senior staff engineer, mostly on performance, developer productivity, and architecture and stuff like that. And to start the talk, let's just start with the problem itself. So what are we going to try to solve with this talk and with the stuff we're going to discuss here? So imagine you have a code base that relies on fragments, and I'm sure that you don't have to imagine that because most likely you have such a code base. And everybody's excited about Jetpack Compose, but it's not that simple. You cannot just add new dependency to the project and call it a day and start just using Jetpack Compose. There are some tricky parts here. Even though Jetpack Compose overall, it's kind of it's compatible with the legacy UI toolkit on Android, but still there are some issues that needs to be solved. So you have a screen that is fragment and another screen which is like a composable screen. So how can you navigate between them? Because most likely you have different scenarios of navigation in the app. So for example, you have an old fragment and you need to navigate to a new screen which is compose. So you need to somehow be able to efficiently navigate without writing a lot of boilerplate and some unnecessary code. Of course, you need to navigate between compose screens in your app, which is like essential. But also you might find yourself in a situation when you created a new screen, but you need to start some old flow from that screen, and which means that you need to navigate from composable function to a fragment. And it's better to be an efficient way because it doesn't look to be, by default, it doesn't look to be very concise way to do it. And overall, while solving these issues with navigation scenarios, it would be nice to have a unified navigation mechanism so that each time you don't have to use different APIs, right? And also, it would be nice to have a proper Jetpack Compose experience. And by this, I mean that when Google promotes Jetpack Compose, they tell you that you can have a function, you just put a composable annotation over that function, and that's it. You can write your UI. So we want to stick with this experience. We don't want to force anybody to write some wrappers or some bridging or adapting code, which is just a bunch of boilerplate, which is not fun to write. And of course, we want to, while we are exploring these navigation options, we want to have backstack configuration changes and everything handled by whatever tooling we're using, so that we don't have to re-implement it. So and basically how it started at Turo is that we wanted to adopt Jetpack Compose, and we started to develop a new architecture that will work with Jetpack Compose and help to adopt it and help the engineering team to start writing new features with Compose. So initially it was developed internally at Turo, but just a few days ago it was open sourced, so you can find it on GitHub as a Nibel, which is basically a navigation library that provides a type-safe way for navigating. Basically, it handles all the stuff that we're going to cover in this talk, and in particular in this talk I want to cover what is our experience at Turo of working with these use cases, and what experience you can have if you try this library and integrate it in your project. So all right, so let's just start with the basic stuff, basic navigation. So the way how we solved it is that, for example, when you have a composable screen, you have you just put composable annotation, and the way how we do it is that we also put a UI entry annotation. And you can see there is a thing called implementation type, so let's just forget about it. Let's just see that, okay, we have some additional annotation. And what this annotation does, it actually generates some code. So we're using some custom Kotlin symbol processor that analyzes this annotation, and it actually generates a class for this composable function. And what this class is. So when you navigate from fragment to this new compose screen, which is annotated with UI entry, basically the UI entry annotation generates a class called full screen entry, which is actually a fragment. So the way how it works is that we just take the name of the composable function and just add entry in the end of it. And now you can create the instance of a fragment. And when you just need to navigate from some existing fragment to this new compose screen, the world outside of compose sees that new compose screen as a fragment, and you can just perform a simple fragment transaction, and there is no any some challenging or like some weird APIs that you need to use in those old screens, which So you just instantiate the instance of that entry. Even though it's called entry, we can just treat it as a fragment, and we perform a transaction the way we want. All right, we have another scenario, compose to compose. So again, let's get back. We have our composable screen. We are putting some annotation. We have another screen, and we can also put arguments in that annotation. And we can use those arguments as a parameters of a composable function. Those arguments must be parseable of parseable type. But now we have like two composable screens, which use some code generation magic. So how to navigate between them? So in the full screen, we can use a navigation controller. We can pass it as a parameter, and we'll next in this talk we will see how it works under the hood. But basically, the library figures out how to provide the instance of the navigation controller, so you don't have to bother about it. But basically, we are in the full screen, and you remember the second screen was bar screen. So in this case, what we just do, we just use navigator.navigate. We are using the generated bar screen entry, which is creating an instance of it, and we just perform a navigation, and that's it. And the implementation and all the stuff is handled under the hood. And if we need to navigate from compose screen to a fragment, some old fragment, so let's say we have a buzz fragment. I know names are very cool, but stick with me. So we have this fragment, and we have a composable function. So if we need to navigate from a existing composable function to like fragment, we just need to create an instance of that fragment, and we just wrap it with a fragment entry, which mimics the like logic we had with entries in previous generated snippets of code. But this way we can just wrap the fragment with some simple wrapper, and navigation will be performed. So all right, I mean this was the like very brief overview of how it works. Of course, it has like a bit more functionality to it, and we will definitely see that. But I want to make a step back and overall reiterate on this thought process of like when this was developed internally at Turo. So like, what was this thought process of like why it looks like this like right now? So why is it? So when you start thinking about how to adopt Jetpack Compose in existing fragment-based code base, you just need to decide, okay, so how can you make them compatible? So the easiest way to do that is that when you create a new composable function, like full screen here, right? You can just write a simple wrapper, which is a fragment. You can call it full fragment, right? And it will have on create view function, and again the Jetpack Compose API and all the compatibility stuff allows you to have a Jetpack Compose function as a content of a fragment, which is nice. But the problem with having a fragment is that you kind of have a temptation to go over the bounds of a compose world, right? Because you can have defined some custom functions in that fragment. You can have some state, like just some variables in that fragment, and you always have a temptation to use them. And also it's a fragment, which means that you have access to APIs of a fragment, which kills partially the purpose of Compose and does not make the experience like a proper Jetpack Compose as it was meant by Google when they developed it. So okay, I mean, what we can do is that we can move this like on create logic and all this stuff, this boilerplate. And in practice, there is even a bit more boilerplate, but yeah, I just reduced it for the sake of presentation. What we can do, we can create a base class, which is a composable fragment, right? And what we can do when we create a compose screen, we just need to create a simple, again, full fragment. But now it will be even simpler because it just extends existing composable fragment, which is a base class, like abstract class, that has all that logic hidden, and it just exposes to you some abstract composable content where you can put a function. I mean, that's definitely much better, but the problem is kind of still remains. Yeah, so we have less boilerplate code, but on the other hand, we still have access to APIs of fragments. We can still have some, state and functions and stuff like that, which again, it's not a proper Jetpack Compose. It can be simpler. But if you take a look at this class, it kind of looks pretty straightforward. So you just create a new class, which just extends another base class, and it has one override function, which is a composable function. And you just need to put the right reference to your actual composable function. So what if we just do a little bit of code generation magic here? So instead, okay, we can just use a UI entry, which means that for this composable screen, we'll just generate like this fragment, right? The base fragment class that uses base fragment class, but it will be hidden from our eyes, and it looks pretty simple. And this is basically like everything narrows down to this idea. So again, implementation type means that for this composable function, we generate a fragment. And actually, we can generate something else. Yeah, just stick with me. I will go there as well. So yeah, and here is the generated fragment. Pretty simple. Yeah. But we don't have to write it manually. We just use whatever was generated for us. And again, we have navigation. So let's get back. We have a full screen and we have bar screen, which are two composable screens, but in fact, they're two fragments. And those fragments just use those composable functions as their content. So when we want to navigate from one screen to another, most likely we'll use just fragment transaction under the hood. So when we use this like navigator, navigate to, and we are passing instance of a bar screen entry, which is again is a fragment, generated fragment. So what happens under the hood is that we are performing the fragment transaction. But this API is hidden, so like as a user of this like library architecture, you don't have to bother about it. You just you're just expressing your intent. I need to navigate from one screen to another. And yeah, so the naming again, we have bar screen and just like using this entry so that we have reference to that fragment. But we need to think here about a little bit of an optimization. Let's say you're writing new feature that consists of like 10 composable screens, and with this approach, you will generate a fragment for each composable screen, even though the only screen from those 10 screens that kind of interacts with the old code base, maybe like the first screen, so that when you navigate from the old fragment to this feature, you just navigate from the old fragment to this new screen. So we need a fragment only in one particular case. And now, then in those following like 10 screens, we don't have to have fragments to navigate within them. And we actually can have some performance improvements if we avoid using fragments for navigation inside of those screens, because we can just avoid a bunch of class allocations when we like opening those screens. Because we can just use some means for pure compose navigation. And what we actually do is that there are cases where instead of generating a fragment, we're generating something else. So in this case, we can see we are generating bar entry, but this is not actually a fragment. It extends composable entry, and it's very simple like wrapper class, the sole purpose of which just to have this abstract function composable content, where again you just put the reference to your screen. And basically this is what lies in those this is the logic that lies behind the implementation type. So when you use implementation type fragment, a fragment is generated. And by using implementation type composable, we just generate another class, which is very lightweight, it just like needs to conform to a few protocols and like some interfaces and stuff like that. But inside, it just like it's a holder for a single composable function, and you have much less allocations for class allocations, because actually there is no fragment that exists for bar screen. And again, when you navigator like navigate to bar screen entry. So what should happen? Because now bar screen entry, it's actually not a fragment, it's another class, right? So how should we behave in this case? How should we handle it? And this is like the core idea that lies like behind like this talk and this project, is that we can just have an abstraction over navigation, which we already saw. Like, right, we don't use fragment transactions manually. We just delegate it to some navigation controller, which does it under the hood. But what if we can, use some different tools for navigation in different circumstances? So let's imagine we have our screen. So again, this is a composable function that has implementation type fragment, and hence a fragment entry is generated for this screen. So how the navigation works under the hood? So when you use navigator.navigate to, what happens? It checks, okay, so next screen, next entry, what is it? So in our case, next screen has implementation type composable, meaning that there is no fragment generated, there is some just proper class generated for that. So in this case, instead of a fragment transaction, we're just using compose navigation library provided by Google. But what's interesting is that this compose navigation library is not exposed to the user of the library. So you don't deal with it directly. It's just an implementation detail which is hidden from you. It's the same way how fragment transactions are hidden. So again, if we navigate from a screen which is implementation type fragment to a screen which is implementation type composable, a compose navigation library is used under the hood. The same way, if we navigate between two purely composable screens, again, we can perform a compose navigation. But again, this happens behind the scenes, like under the hood. And another interesting case is that, okay, you have this screen which has composable implementation type, which is, again, it's not a fragment. And what if you need to navigate to a fragment? So in this case, what happens? The navigation controller that we are using, it just search for the closest fragment in the backstack. In our case, it's a first screen, which is as well, it's a composable function, but it's wrapped with a generated fragment. So if we need to perform this navigation, what we just do, we just perform a fragment transaction between that first initial fragment entry, and the next fragment, which is like old screen in our flow, right? But to the user, it will look like we're just navigating from this third composable screen to a fragment. But the transaction will be performed under the hood. And in order to perform this, let's go to this composable fragment, which is a base fragment we saw before, but now it has a little bit more logic to it. So now we're using this onCreateView function where we can set up the view and the UI for our screen. But in this case, we're using compose navigation library. We're using navhost, and compose navigation library tells you that you need to use this composable function, and inside you need to use actual composable. So the content of this fragment, composable content is used as a destination of a navigation library. So again, this is a base class for all generated classes. And the way it works is that, okay, if you're opening the screen, you just have a navhost with a single destination, which just has this function. And if you need to navigate to another composable screen, so you don't have to perform a fragment transaction, we just add new destination to the compose navigation library dynamically. So, right, our documentation for compose navigation tells that you need to define all the destinations using this composable lowercase function. But in fact, with some hacks, you can actually add those things dynamically on demand, because and you don't have to track them in a single place. You just once you perform the navigation, you just add that new destination to the navigation graph, and you just perform the navigation. Yeah, and I just want to go back to the code. Just for 1 second, Ryan, can you tell me if you can see my IDE right now? All right. I hope yes, but
yeah. Yes, we can see your ID.
Oh, awesome! Thank you. Yeah, I just want to show like a quick demo, like what is the experience in practice, right? So let's say so this is a repository with this library, Nibel. So it's open source. You can just check and try it for yourself. And yeah, so I just created here like a simple file, and yeah, we have full screen. Let's just define function. We just make it composable, and UI entry. So this is all we need to define a new composable screen, and here it will be just composable content. So when we build the project, just give it a few minutes. Yes, I have an emulator here. Let's just forget about the emulator for now. Let's just see in code. So we can go to the build directory, go to generated KSP. Let me just find this. Okay, so now for our composable function, we have a full screen entry generated, which is again composable fragment, and it uses our compose function as a content. So if you command click here, yeah, we can see this function. Okay, we can define another full screen. It's a bar screen. Again, composable, and again, UI entry. Again, let's make it implementation type. Let's make it fragment for now. Or I think we can make it even composable. And we can specify arcs. So let's define that a class bar arcs. Random value, I don't know. Let's make it parcelable. And let's make it parcelize. Okay. And here we can just, we can do the following. Just bar arcs class. So, I mean, yeah, this is how we need to define the screen. So we have arcs here, but okay, let's build the code again. So if you go to the generated code, we have a bar screen entry right now. So now it's not a fragment, it's a composable entry. And you have, again, content of composable content here. This function has no arguments. So how can we access those bar arcs, right? What can we do is that arcs, bar arcs, and we can build it again. And if we go to the bar screen entry, now the code generator figured out, okay, I know what arcs is, and I know how to provide it. And basically just, retrieve those arguments and it put them in the bar screen. But what's important is that the type of argument should be the same as in the annotation. Otherwise, you will have a compilation error. And similarly here, okay, we need to perform navigation from full screen to bar screen. Let's again close the emulator. So what are you doing? Just put here navigator, navigation controller, and you just use, okay, I'll create instance of arguments, bar arcs, something, and then navigator, navigate to, just bar screen entry, new instance arcs. Okay, so again, I'm building the code, and in the full screen entry, now we have a navigator which is provided to us, and like the name of this parameter can be it can be any name, but yeah, there are some special types that you can put here so that it will be provided for you by default in the fragment, for example, or like in any generated code. Yeah, and also what it can do is that you can have a view model, for example, view model, but just use, for example, this way. So this way, the function has a default argument to it, so it doesn't matter. You can just build the code again, and again here the full screen has a navigator, but if you see what arguments it also has like view model arguments. I hope I hope the size of the text is fine. Yeah, and finally, let's just forget about this particular demo. We can just run the sample app. So it has a bunch of screens just to demonstrate the idea. So we have a first screen which has implementation type fragment, and we have a second screen which has implementation type composable. So if you go to the app, I hope size is fine. Okay, yeah, so let's open first screen. So it tells us, okay, this is a first screen. It's a Jetpack Compose screen, and implementation type is fragment. So let's put some arguments, and let's move to the second screen. Okay, so now we're in the second screen, Jetpack Compose screen, and implementation type is composable now, meaning that for the second screen, so that let's verify that I'm not lying to you. For the second screen, there is a second screen entry generated, which is a composable entry. It's not a fragment. And if you go here, just a very simple class with abstract function. But yeah, so what can we do? What's the point of abstract navigation? So let's go back to second screen. Let's change it from implementation type composable to implementation type fragment. And let's build the app again. Okay, so if we go back to the second screen entry, so now it's completely different class. Now it's a fragment. And you can notice that the code is compilable. So even though this is a completely different type of class, this is a fragment, which was not the case before. When we navigate from the first screen here, so we have this navigate to, we just put second screen entry. It doesn't matter what instance is it. The library and the framework can just figure out what type of screen is it, and it can use the appropriate tools for the navigation. So again, let's open first screen. When we open second screen, so second screen now is also implementation type fragment. However, it was composable before. Yeah, so you can easily switch different types of screens, and navigation will be still unified. So yeah, I think, and this sample project is in the same repository with the library. You can just open the GitHub repository, and all the stuff is available here. All right, let's get back to slides. There is one more thing to discuss is multimodal navigation. And what is the problem with multimodal navigation and why it's different? So normally, in many cases, when different companies or apps, like engineers, when they design architecture for multimodal architecture, in many cases, when we have feature modules, they usually do not depend on each other directly. Which means that if, for example, feature B on this slide, if it has, for example, some screen entry generated for the composable function, and if you want to navigate from a screen from feature A to feature B, you're not able to do it because you don't have a direct reference to that generated code, right? Because that's a different module and they do not depend on each other. So how Nibel can help with it, and how it was solved for us. So we can use a separate module called navigation. It's a very simple module. It should not have any logic, but its main purpose is so that both feature A and feature B can depend on it. And inside of this navigation module, we define things which are called destinations. So what destination is, it's a simple data type that defines an intent of the navigation. And destination is connected to a specific screen. So like each destination object can be associated with a one and only one screen. So in screen one, when I use this destination for the navigation from completely different module, I can just, instead of giving the direct reference to that screen or to that generated entry, I can just use the destination and just, give it to the navigation controller. Under the hood, it will figure out where to get the instance of the fragment or of a screen from another module. And let's see how it works. So again, we have a destination module. We just define a simple object which is called destination, and we need to implement destination with no args. Or if you want args, you just define destination which implements different class, and you can give it parseable args. So those simple data classes, I mean, you can see there is no logic in that navigation module. It's pretty lightweight thing. But the key requirement is that both features and both both screens can have reference to that destination instance. And now when we are defining screen, for example, instead of UI entry annotation, we're using UI external entry. And we just associating it with a destination with a screen. And again, each destination can be connected only to a single screen. This way, they are unique entities, and this way we can just figure out, when I have an instance of a destination, I can figure out which screen it belongs to. So again, when you're navigating compose to compose, you can, if those compose screens are in different modules, you can just use navigator and pass the instance of a destination. Or if the screen with arguments, you just give those arguments to the destination itself, and it will figure out automatically. Okay, so when we need to navigate from fragment to compose, we don't have a direct reference to the fragment because it's in different module. But there is a helper function, so you can just use new fragment entry, and you can just give it the destination. And under the hood, it will figure out how to get the correct entry. And the way it does, just there are a bunch of classes, like factories generated for each destination, and by just matching package names, it just like the library knows the package name of each factory that is connected to the destination. So basically, this is the way how it's all matched. But yeah, in this way, you can have an instance of a fragment, even if this fragment entry, right, which is generated for compose function, even if that class is in completely different module. And again, another thing is navigating compose to fragment. So in this case, again, we cannot just reference fragment directly. So instead, we can use a legacy external entry annotation, and you can just put a destination for your fragment. So I can see a typo here. The names of destination and fragment should match, but it doesn't matter. So basically, the concept here is the same. You should have a unique destination that is connected to the fragment. And then when you perform the navigation, you just put this destination, and this way, even though it's an old fragment, right? So this could be an old fragment that exists in your code base for many years, but just by adding this simple annotation, you can now navigate to it from compose screens to an old fragment. And with all that said, so like before that, we just discussed the tools, like how to perform some simple steps, like to perform different navigation, or like how to define screens. Let's combine all of it together, and let's see at a higher picture. So when you are adopting Jetpack Compose in your code base, usually you can go with different scenarios depending on the feature or screen that you're adopting. So the first scenario, let's imagine it's the easiest one, because you're just adding a brand new feature module. So like it's a separate Gradle module, and you have an legacy fragment in some other module, and you just need to navigate to this new feature module. So what happens? So again, the first screen of that new feature, it must be external entry, because you need to reach to this screen from another module, and it should be fragment, because the screen from which you will be navigating to this screen is fragment, and that's why it should perform fragment transactions, so that for the non-compose world, your compose screen will look like fragment. So now that we are inside of the feature, all the rest screens can use just UI entry, because they don't need multi-module navigation. You can have reference to them directly because it's the same module, and you can use implementation type composable, for better performance, to not allocate a bunch of classes related to fragments and stuff like that. And all the rest classes in all the rest screens in this feature, they could be the same. Just use composable implementation type and UI entry for the annotation. However, in this new feature, you can have scenario, like use case. This is still the same scenario, but you can have a use case that you need to navigate from this new feature to some, again, to some existing screen in the app. So in this case, you just annotate that existing fragment with legacy external entry annotation, and you just perform navigation from this blue screen to that fragment, the way using navigation controller, the way we discussed before. So second scenario. What if we need to expand existing feature? Which means that we have some old feature module in our app, which already has some fragments. And we need to squeeze in a bunch of compose screens in the middle of the flow, right? So in this case, again, when you do this, you just create a new screen in your app. You put a UI entry annotation. You make it the first screen. You need to make a fragment, like implementation type fragment, so that you can navigate to it from existing fragment to compose. Subsequent screens in this flow should have implementation type composable. But again, anytime you can navigate from composable to fragment just easily, as we discussed before. And this third scenario, it might be the most common and the most frequent, is that when you just need to inject standalone screens into some flows, right? So you have an existing feature, and then you just need to randomly, when you expand this feature, you just need to randomly add some here and there screens, compose screens, which are not related. So in this case, just for each of those screens, use implementation type fragment, and for other fragments, those compose screen will look like fragments, again, as we just discussed. So yeah, in this, if you just need to add a single screen, just use implementation type fragment, and it should be good. All right, yeah, so this is basically the main idea. If you're curious to learn more, I published a bunch of blog posts about that. So you can check, you can go to Turo Engineering Medium blog. I published one article regarding how it all works under the hood, maybe a bit in more detail. And another article is specifically about this open source tool and how can you use it in the project. Because yeah, there is more interesting details to it than I can squeeze in a single talk, so that it's not feeling like too overwhelming. But yeah, if you're curious, please feel free to check those articles. And yeah, that's pretty much it. And now I'll be happy to answer any questions if you have.
All right. Awesome talk, Pavlo. So yeah, we'll just give the viewers just a moment if they have any questions. I have a couple myself, but
Yep.
I just wanted to comment. I really appreciated how you went, the level of the depth you went into with how things work under the hood with your library, because I instantly had some questions about it, and you covered that in like a perfect level of detail where it wasn't super deep dive, but made it clear what was happening. So great talk.
Mm-hmm. Yeah, thank you. I appreciate it.
All right. So I think I'll start off with one of my questions, which was, so when you were either in the process of like building the code that became the library or the library itself, was there any sort of use case or situation which stood out as being like a big challenge for you or your team? Or is it all pretty smooth?
Yeah, so I think challenges arise gradually, like as more you move forward, the more challenges you have. But yeah, I think the biggest challenge that I wasn't sure if it would be possible to implement when I was like designing it is that this transition between, okay, in this case I use fragment transaction, in this case I use compose navigation, and how to make it smooth so that it's not exposed to the user. The library just figures it out automatically under the hood. Yeah, so I think that was the most challenging, because when I mentioned that, unlike the general use case, how Google suggests using compose navigation library, when you define all the destinations statically, right, like in one place. When you do it dynamically, compose navigation library, it's kind of does not support it fully. So when you add destination dynamically, and when you have a configuration change in your app, it does not persist those destinations. So it remembers that there is something in a backstack, but when it tries to restore it, there is a crash because it does not persist dynamically added destinations by default, because those destinations are added not on the level of Compose navigation library, but on the navigation library, which is like under the hood of a Compose. So basically, there was a challenge, to automatically retain those Compose destinations and restore them on configuration change. Yeah. I hope that makes sense.
Yeah, no, it does. The other question I had, so when I was kind of making this decision of like how to essentially, I guess, build an architecture for navigation in Compose, albeit in my case, this was just for like a little project of mine. It wasn't for an existing app. I noticed that there are some existing third-party libraries and solutions. I'm not really familiar with any of them in particular, and there were reasons why I didn't bother to look deeply into them. A big thing for me is I wanted to see, can I build a solution myself? But my question to you was like, did you or your team spend much time evaluating certain third-party options? And there's no need to like name names or anything, but was there anything that pushed you away from using any of them?
Yeah, this is a good question. Yeah, I think it's an obvious question that people frequently might ask, because there are some libraries that also use code generation. In some ways are pretty similar. That you just annotate a compose function, it does something for you. But the problem with those existing navigation libraries was that they work very good when you navigate from compose to compose, right? And they do not solve the challenge of compatibility. So when working on this particular library and thing, so the challenge I had, for example, when working on it, is that we need to somehow have a way to navigate from fragments to compose, and then from compose to fragments, in some unified way, so that it's just not an abstract compose app, but we are living in the environment where, in the reality where, the majority of apps in our industry, they have some legacy code. In most likely it's fragments, but not necessarily, but still. So the main challenge that those libraries do not solve is that they do not provide compatibility with fragments. So you need to still figure it out for yourself in those cases.
Oh, there we go. Can you hear me now?
Yep, I can hear you.
Okay, good. So for some reason it disconnected me, and then when I reconnected, it left me on mute, which
Oh,
a little bit to
no
figure
worries.
out. Okay, so I'm not exactly sure. We're having some kind of technical difficulties. Could be my internet or something like that, or maybe it's just our service provider here that has caused us a little bit of trouble today. Won't name any names which service we're using. But thank you so much for your talk. I had one final question, if our
Yeah, of
connection
course.
here will follow up, which is, are you running like some kind of beastly laptop or something like that? Because the build speed when you're running through the live code demo just like blew me away.
Oh, that's a nice question. I mean, I'm using M1 laptop, but the reason why it's so fast, because I ran those builds before. So
Okay.
the Gradle remembered, even with those code changes, it just restored them from cache. Yeah. So in real life, it's a bit slower. It's not that fast.
Okay. Well, I should expect as much from a staff sort of infrastructure engineer knowing these sorts of things. So, all right. Well, I think, that'll be it for all the questions. Thank you so much, Pablo, for the talk.
Thank you.
Take care.